All right. 3.1 is the Triangle Sum Theorem. The first definition that we have is of a triangle. All right. We all know what triangles are. We know what their properties are, but it's good to review that. A triangle consists of three non-collinear points. Okay, so 3 points not on the same line, and the line segments connecting them. All right, so three non-collinear points, and then you have three segments that connect them. Now, the name of a triangle. Tri means three, and then angles. You have three angles. But how do you most likely, in the past, what do you normally consider a triangle? How would you describe a triangle? When you say it has three sides? That's what a triangle, oh, that's a triangle, it has three sides. Well, it's actually named based on its angle. Okay, it says three angles, and those three angles are created by three sides. Now, classifying triangles. Triangles can be classified by both its side lengths and its angle measures. All right, so there's three angles and three sides. You can classify them based on its sides. You can classify them based on its angles. Okay, think about classification like this. Think about it as Auburn High School. All right, if I'm going to divide Auburn High School up into different classes, all right, think about what's the most common class that you're divided up into right now at Auburn High School as students. Sophomore, junior, senior, right? That's a classification, isn't it? It's describing a group of people based on the year they're going to graduate, right? Okay. What other classifications at Auburn High School do we have?
Math, history.
You have people enrolled in different subjects. You have students right now in first block. You got a class of math people, in different sections of math. So you can even divide up. Let's say everybody that's in geometry right now can be divided out even further. You can be described as students in first block geometry classes, but then you can even get more specific and say geometry students in Coach Ramsey's class, geometry students in Coach Roberts' class. So what else? I think it's a very simple one. What makes up this classroom right now?
Boys and girls.
Boys and girls. It's very simple. Boys and girls are two classifications that a group of people can be divided up into. Okay, you hear a lot about this in history class, the different classifications of people throughout history. Middle class, lower class, upper class. Different things there. Okay, a classification or classifying something is that's what it is. You're describing something based on some properties of when you're going to graduate from high school, properties of boy, girl, properties of different classes that you're in. Okay. Now, if you're going to describe a triangle by its sides, there's three different classifications that you can identify. The first being an equilateral triangle, which we know what equilateral means. The second being isosceles. The third being a scalene. All right, an equilateral triangle. An equilateral triangle. You have three congruent side lengths. Remember, congruent means equal. Right. We talked about the word equilateral in the last section. Equilateral meant a regular polygon. Okay, it means all the sides were the same. If all three sides are the same, you have a triangle. It's equilateral, so we call that an equilateral triangle. So those two definitions, you should have put those together already, just based on the last section. An isosceles triangle. Now, these next two, isosceles and scalene, there's never been a test or a semester that's gone by where somebody, and not just one person, but multiple people, get these two definitions confused. Okay? They get these two definitions confused all the time. They know that the two triangles are different, but they'll name an isosceles triangle, a scalene triangle, and vice versa. All right, so an isosceles triangle. Isosceles triangle. They have at least two congruent side lengths. At least two congruent side lengths. Now, that definition can get a little confusing because it says at least 2, which means it could have what? It could have 3. So, is this triangle here also considered a scaling triangle? I'm sorry, an isosceles triangle? It is. All right, it's also considered a isosceles triangle. Now, this is generally how you're going to identify an isosceles triangle. You have 2 sides that are congruent. Now, you're going to name, when you have directions, it's going to say name things the most specific way. If it's got 3 congruent sides, you're going to name it equilateral. If it's got 2 congruent sides, it's going to be isosceles. Does anybody know a trick just based on looking at the word, how to remember which one's which? This is how I remember it. You have 2 S's at the beginning, right? Isoso, it's pretty clear. You got those 2 S's at the beginning. How many congruent sides do you have? 2. All right. So that's how I remember it. All right. Whatever trick you need to come up with, if you just need to learn it, then learn it. All right. But don't get these 2 confused. I'm telling you, it happens every semester. It's going to happen again. Don't let it be you. All right. A scalene triangle. Scaling triangle is very basic. All 3 sides are different. All 3 sides are different. If you got 2 sides that are the same, it's going to be one of the other 2. All 3 sides are different in a scalene triangle. Any questions? All right, along the same lines as classifying by its sides, you can also classify it by its angles. All right, so you have the same triangle. You can classify it.
Excuse me, teachers, this is an all-call test. All-call test. Excuse me, teachers, all-call test.
So you have the same triangle. You have sides and you have angles. You can classify it by its sides. The same triangle, you can classify it differently by its angles. All right. The first being an acute triangle. An acute triangle. All right. All 3 angles are less than 90 degrees. All 3 angles are less than 90 degrees. All right. 3 acute angles. If you have a 90-degree angle, it's not an acute triangle. Remember, acute angle is less than 90. Okay, not equal to 90. All right, an equal angular triangle, you know what equal angular means? It means all the angles are the same with a triangle, so a triangle with 3 congruent angles. All right, a right triangle. A right triangle has exactly 1 right angle. Exactly 1 right angle. Question, is it possible to have a triangle with 2 90-degree angles? Why not? Why would I have to have 4 sides? Just pictorially look at it. I have a 90-degree angle and a 90-degree angle. Is there any way to close it? What about mathematically? How could you show that? What does the triangle's interior angles add up to be? We've already learned that. 180. So if I have 180, and I know one of them is 90 degrees, plus 90 degrees, plus a third angle, doesn't that say 180 equals 180 plus the third angle? And if I subtract that, I get 0 equals x. Do I have a 0-degree angle? I can't have it. So mathematically, you cannot have something more than 90 degrees, or you cannot have more than one 90-degree angle, both mathematically and you can look at it using a picture. All right, an obtuse triangle has exactly 1 obtuse angle. We'll ask you the same question. Is it possible to have 2 obtuse angles in the same triangle? Why not? what if one angle is 91 and the other angle is 91 plus the third angle, 180 equals 182. That third angle would have to be x, wouldn't it? I mean, the third angle would have to be a negative angle. Do we have negative angles? We don't. So exactly one obtuse angle. And I could have done that with any obtuse triangle or any obtuse angle. I can't have more than one for that very reason. Questions? Yes, sir. Higher than 90, but less than 180. All right. Triangle ABC can be written as triangle ABC. All right. That's a little symbol that we can use. Basically just a little mini triangle out front, and then using the three vertices of that triangle as naming it. All right. It's an isosceles triangle. Segment AB is considered the base. Segment AC and CB are legs. Angle A and angle B are the base angles. The base angles of an isosceles triangle are congruent. Now, let me point these out to you. The two sides that are congruent, are considered the legs. All right? So in an isosceles, you're going to have two sides that are congruent and the third one that's different. The two that are the same are called the legs. All right. The third side is considered the base. So the two legs that are equal or congruent are the legs. And this would be the third side. Up here. Equal or congruent. The legs are equal or congruent. The two equal or congruent sides. Now, the base angles. Now, the base angles share a common word with base. All right? Base and base angles. The base angles. Pay close attention to where the base angles are. If I have my base here, my base angles are where my leg and base meet. Where the leg and base meet, those two angles are considered base angles. They are also opposite the leg. Okay? If you look directly across from the leg, you have a base angle. Each leg look directly across, you have a base angle. Questions? All right, the triangle sum theorem. We have already proven this. We've already looked at it. We looked at the visual proof of it last week. It says the sum of the measures of the angles in a triangle equal 180. Interior angles out to be 180. All right, so that's the triangle sum theorem. The next postulate is the parallel postulate, and it's kind of out of the blue right now, but it's in here. All right, it says given a line and a point not on a line. All right, so I have a point and I have a line that's not on, or a point not on the line. All right, so that's what I got. there is exactly one line that contains the point that is parallel to the given line. Okay? There is only one option of a line that goes through this point that is parallel to that line. Exactly one, no more. Because any way you shift that line that goes through that point, you know, up or down, a line here, line there, all of those are not going to be parallel. There's only one point, there's only one line that will go through that point that is parallel to the given line. Now, if I pick a different point, how many lines would go through that line? Or how many lines would go through that point that are parallel? Exactly one, right? If I pick a point down there, it'd be exactly one line that would be parallel to the given line. Okay, so you can pick a point anywhere. The thing is there's only one line that will go through that one point that's parallel to the given line. Does everybody have a parallel line postulate? All right, example 1. Given triangle ABC, prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. That is the interior sum theorem, the triangle sum theorem. All right, the interior angles of the triangle add up to be 180 degrees. We've done this using a paper triangle. We tore the edges off, taped them together, it made a straight line. Well, now we're actually going to prove it mathematically. Okay. The first thing when we try to prove something is we have to state what we know. Okay. What do we know? Now, notice the fact that it gives us M is parallel to AB. All right. So the dotted line is parallel to the bottom side of the triangle. I'm trying to determine that these three angles add up to be 180. What angle measures or what group of angles do we know equals something right now? Three, 4, 5, right here. Angle 3 plus angle 4 plus angle 5 equal 180 degrees. Does everybody feel? I mean, everybody understand that? Everybody see that? Those three angles form a line. Therefore, they equal 180 degrees. Now, anytime that you have parallel lines, what can you always think about? I told you you're going to use them for the rest of the semester. What's it called? What's that called? It's a transversal, right? The two green and the yellow create a transversal. The yellow is the transversal. The green are the parallel lines. Now, angle 1 is equal to angle 4. They are alternate interior angles. All right. BC is another transversal that divides two parallel lines, which tells me that angle 2 and angle 5 are alternate interior angles. Now, if we know that angle 1 equals angle 4, angle 2 equals angle 5, then what I can say is angle 3 plus angle 1 plus angle 2 will equal 180 degrees. That is by substitution. All right, all I did was substitute in. If 1 equals 4 and 2 equals 5, then I can substitute in 1 for 5, or sorry, 1 for 4, 2 for 5. And there's my proven statement. I've proved that the triangle sum theorem will equal 180 degrees. Did anybody notice that we used the parallel postulate in this? All right, so I took a triangle, real small right here. I took a triangle. There was AB. There's a point up here that's not on AB, right? I can create a line M. I can create a line M. I mean, it doesn't tell me I have to, but when I create that line, I have angles 4, 3, and 5 that I know line M is parallel to AB. So we created that parallel line not by any fancy, not using any fancy tool or any fancy math, but just by using a postulate. I just put that parallel line in there to help me prove my statement, and I could do that for any triangle because I can make that third side that's non-collinear. All right, it's not on the same line as the other two vertices. And take that point and create a parallel line that goes through it. All right. Example 2, you need to get that bottom paragraph. All right, so a little background on example 2. It says Adrian works for a company that reinforces homes for earthquake protection. It says the company fabricates and installs stainless steel supports that are connected to the foundation and the house at the corners of the building. So these supports are fabricated in the shape of an isosceles triangle. Now, here's what it's going to look like. You have these concrete bricks, okay, at the corner of your house. All right. Well, normally they just they use these concrete bricks and then they put them in, and that's the foundation for your house. But when you build a house in an earthquake-prone area, which seems to be everywhere these days, what they do is they come in and they put in a metal triangle support. All right, so they fill this triangle in. All right, it's just a little metal triangle that they drill into the sides. It almost looks like the bottom of a bookshelf that's hung on the wall, like a little triangle, an L piece with a connecting rod. That's what it looks like. They put those in the corner of the house, and that helps add support. That way, when the ground shifts, that foundation doesn't separate, okay, as much. Now, Adrian measures the corner of the foundation, which it sounds like she comes in after the fact, after the foundation's already built, to install these. It says Adrian measures the corner of the foundations and finds it has shifted to 92 degrees, which will happen. When they build a house, it's a perfect 90. And then as the ground shifts, different things happen. It shifted to 92 degrees. It says, when she writes the order for the fabrication for the support, what should she specify for the angles of the base angles? Now, this is let me give you a better picture. All right, so I have the concrete support. And now we come in. Wait a minute. All right, so we have this triangle in the middle. We know it's an isosceles triangle, so it's going to be the same here and here. That's the same length. Now, the foundation meets here, so it's 92 degrees. What we want to know is we want to know what angles the base angles need to be. All right, remember, the base angles are across from the legs, or it's where the leg and the base meet. So if this is my leg and this is my leg, this is my base. And those two would be my base angles. Now, what is the definition of isosceles triangle concerning its base angles? Base angles are congruent. So I have three angles. If this angle is a base angle and these two are the base angles and they're the same, we can call that x. Well, we can use the Triangle Sum Theorem to figure this out. We have x plus x, two angles that are the same, plus 92 degrees equals 180. 2x plus 92 equals 180. 2x equals 88. X will equal 44. So each one of these angles is 44 degrees. So what should she specify for the measures of the base angles? They should both be 44 degrees. Anybody still writing? All right, we're going to use the following triangles to answer questions. And we're going to answer these kind of in an order. First thing we want to know is, what is the measure of angle 4 plus angle 1? $180. It's a straight line. All right. What is the measure of angle 4 plus angle 2 plus angle 3? 4, 2, and 3. Maybe we did. 180. It's a triangle, right? 2, 3, and 4 create the triangle. 180. Now, so why does angle 4 plus angle 1 equal angle 4 plus angle 2 plus angle 3? Could I say that? Why can I say that? They both equal 180, right? Now, the D, I'm going to kind of explain real quick. All right, if I take C, where I say angle 4 plus angle 1 is equal to angle 4 plus angle 2 plus angle 3. What's the same on both sides? Angle 4. So if I subtract angle 4 from both sides, it's going to cancel both of those out. And what am I left with? Angle 1 plus angle 2 equals angle 3. So, what does angle 1 plus angle 2, it's actually more like y, does angle 1 equal angle 2 and angle 3? And what we can say is the substitution property. All right. Now, look at the angle relationships of this triangle based on what we just know, or what we've just found out. We took angle 1, and it's equal to the sum of 2 and 3. What can you say about this in terms of describing it? About the relationship between the interior and the exterior angles of a triangle. Doesn't say anything about 180 right now. The 180 helped us set it up. The exterior angle. The exterior angle is equal to what? Which interiors? 2 and 3, right? Where are angles 2 and 3 compared to the exterior angle? What about the sum of the non-adjacent angles? Angle 1 and angle 4 are considered adjacent angles, right? You agree? Okay. So 2 and 3 would be non-adjacent angles to angle 1. So the exterior angle equals the sum of angles 2 and angle 3. And what that gives us is it gives us the exterior angle theorem. Okay, the exterior angle theorem says a measure of an exterior angle of a triangle is equal to the sum of the 2 remote interior angles. Another word for the 2 remote interior angles is non-adjacent. So the exterior angle is equal to the sum of the 2 angles not next to it. Last example, example 3. All right, in example 3, we have triangle ABC. It says find the measure of angle B. There's 2 different ways that you could do this. One way shorter, one way is longer. I'll show you the short way first. Using the exterior angle theorem, it wants you to find the measure of angle B. All right, I'm going to call that X. C, or the exterior angle at vertex C is 110. That's an exterior angle. An exterior angle is equal to the sum of the 2 non-adjacent angles. Well, A is non-adjacent and B is non-adjacent. So what I can say is X plus 60 equals 110. X would equal 50. Right. The exterior equals the 2 non-adjacent angles, interior angles. Now, the other way that you could have solved this is using the triangle sum theorem, that the interior angles add up to be 180. You know that angle C and the exterior angle at angle C add up to be 180. That's a linear pair. So, therefore, this angle is 70. All right, so angle C is 70. So I could say 70 plus 60 plus X equals 180. 70 and 160, sorry, 70 and 60 give me 130. plus x equals 180, x would equal 50. Of course, x being angle B. So two different ways you can solve this. Using the exterior angle theorem, you go straight to it. You got to do a little extra work to get it using the triangle sum theorem. Any questions about the exterior angle theorem? All right, your homework is page 148. It's numbers 5 through 14 all.